Well, our presenter this morning is Michael Hackett. Michael is the co-founder and senior vice president of LogiGear. Michael oversees LogiGear University that provides training for both internal and external clients. He travels extensively providing QA management consulting to corporations around the world. Michael is a certified Scrum Master. He's a member of IEEE. His training has delivered testing expertise to clients in over 16 countries, and he's co-authored 2 books on software testing. Michael, thanks for joining us. Glad you can be with us today. And so we're ready for you to tell us all about technical debt.
Well, thanks, Joe. Okay, well, we'll get right into it because I have a lot of slides to go through. So thanks for joining us. What I want to do today is kind of demystify this idea of technical debt and clarify issues around technical debt, particularly focused on how technical debt impacts testing and what part testers play in accumulating technical debt. So first I want to define technical debt and this famous metaphor. I want to talk about the causes of technical debt, talk about a couple of Agile and Scrum basics to help prevent accumulating more technical debt, and then I want to get into technical debt, particularly to testers, and spend as much time as we can on how testers accumulate and can get rid of technical debt, and then talk about recognizing and communicating debt, particularly with risk and risk management, and then finish with talking about some recommendations for how to prevent debt and how to deal with debt, and summarize what we talked about today. So first I want to talk about technical debt for the whole team. So technical debt is this idea. It was a very specific definition that Ward Cunningham, I think a lot of people know Ward Cunningham. He was a pioneer in extreme programming. He wrote the first wiki. He wrote the FIT harness that a lot of people use. This financial metaphor of debt, what you owe, and it originally referred only to refactoring. So I want to just briefly talk about refactoring. Refactoring is cleaning up your code. It's a disciplined technique for restructuring existing code to make it run faster, have it better commented, have unit tests without changing the outside functionality. So technical debt was really intended to be about refactoring and cleaning up your code, and it was a developer thing, programmer thing. Metaphors really become unmanageable, where people talk about good debt and bad debt and interest and principal and mortgaging and remortgaging and futures, and it's lost sight of the original problem. So what technical debt has come to mean in general is anytime the team decides we're going to do it later, or we're going to fix it later. If we have a problem with our continuous integration harness, if we're going to fix it later, that's building technical debt. Anything that we put off or postpone is considered debt. And debt comes due with interest. Whether it's reworking or throwing something out that we did kind of quick and dirty to rebuild later, that's interest. Joanna Rothman describes it as anything you owe the product. I like that definition because anything that you owe the product could mean even some documentation. So technical debt is about what you owe the product anytime you say we're going to do it later. I have this list of technical debt ideas Holford that I think is kind of interesting for people to look at, like lack of test coverage, misused APIs, redundant code, inappropriate or misunderstood design patterns, black box components where you have no view into how the thing works, overly long classes or functions, multiple or obscure configuration file languages. Technical debt is more than just about the functions that we're releasing. It's more than just about the user stories we're trying to push out to our customers. On this slide, the top suggestion, the top idea he has, missing or inaccurate comments and documentation. That's technical debt. One thing I want to drive home during this is some people really wrongly think that technical debt is about bugs. Technical debt is not about bugs, and we need to stop this notion. I just saw a paper published by a big organization that technical debt was only about bugs, and that's clearly wrong. That's not what it was intended to be, and I see a few problems there. One, that this idea that technical debt is about bugs can really have some teamwork problems because bugs are always associated with the testers, right? And if accumulating technical debt means to some organizations accumulating bugs, there'll be a blame for testers for not finding the bugs earlier or not finding them sooner or for not dealing with them properly. It's also an easy way out to explain technical debt as just being about bugs. Where this list that I just ran through, none of it has to do with bugs, right? Missing or inaccurate comments or documentation about the functionality has nothing to do with bugs. So if you want to call them issues, this idea of issues being different than bugs is a long-standing distinction in software development, that issues are things that we have to do. Persistent issues or open issues that are different than bugs. That's fine if you want to call them issues, but technical debt is not about bugs. Also, one other thing is bugs tend to be communicated and handled and managed very differently. Most teams still use bug tracking systems, even though strict by the book Scrum doesn't talk about having bug tracking systems. Most people still use bug tracking systems, so there's already a system in place to handle bugs and deal with bugs. So why is it so important that we recognize that we define technical debt and have a good working definition for it? First is to recognize it so that we can manage it and deal with it, reduce the interest payment where we can, schedule it, get it done as fast as we can, know that when we're taking on debt, what the rework is going to cost us, know what that interest is going to cost us, and also to actually fix the causes. A lot of technical debt is by Scrum and Agile practices that, if they were fixed, would be accruing less debt. So the whole idea of defining technical debt better is to deal with it better and fix the problems, fix the root causes. A lot of companies are struggling today with everything from governance to measurement and management and prioritizing debt and how you accrue debt and how you track it. That is the subject of a lot of writing these days, a lot of magazine articles and a lot of other webinars. What I want to focus on today is particularly debt and testing, not necessarily the corporate issues of measuring and managing and prioritizing debt. So technical debt happens. It's not necessarily a bad thing. Software development happens over time. Software development unfolds. It's not a nice linear process. Anybody who's worked in development projects knows the further you get into a development project, the more complex it is. And most organizations don't fully grasp how complex development project may be until they get into the nuts and bolts. So estimating and managing and scheduling software development has always been, part magic. So technical debt happens. You can get into the middle of a project and realize, wow, this is more complicated than we thought. The user story wasn't as detailed as we thought it was going to be. So it's going to take us longer than we expected, so we're just going to do what little we can to get the function out and then fix it later. That's building debt. Also, this just-in-time nature of Agile, borrowing just-in-time from lean manufacturing, lean software development, just-in-time architecture and just-in-time design can create technical debt. That you can, design things on the fly to suit your need. May mean rework. It may mean putting off other work. It may mean clean up tasks later on. And oftentimes, product owners who write user stories, they write them too big. They write epics. And one of the main things I see in my work when I go out to companies is that there's a big complaint about how user stories are written, that they're either epics or they don't have enough user acceptance criteria that people would understand better at the sprint planning meeting what is involved in getting this story done. So the user stories are too big. When the team finally gets into working on it, they're not going to be able to get the full breadth of the user story done, so that's going to create some debt. And also, teams not using spikes. Some people will call will have what they call an iteration zero. That I know that's a very political topic these days in Scrum, or a spike where you have a sprint where you're not going to release software at the end. It's not going to be potentially shippable software. A spike is more like an R&D. We're going to set aside this time and discover how the product works, or discover how we're going to develop this, and before we can fully estimate it. That has been a beneficial practice for a lot of teams who don't want to make commitments to delivery on certain user stories, knowing that they'll accrue debt if they don't do an R&D spike to have a better grasp on what's actually going to be delivered. Other reasons why technical debt happens. Some people are just bad estimators, or they'll make consistently unrealistic estimates, or they'll be pressured into certain estimates. When the estimating practices aren't good, technical debt always happens. And some teams are really very pressured to get it done, get it done, get it done. We have to get this user story done. Get it done at all costs is going to accrue technical debt. And with the very short time frame nature of sprints, oftentimes teams only get to focus on what's absolutely essential to get something done rather than good software practice. So one thing that I want to make, a distinction I want to make here is, I think anybody who's using Agile practices or Scrum or XP practices has to understand Lean software development, because Lean has had a very big impact on what we call Agile these days, and I have a slide on Lean in a little while. But one of the first principle of Lean is to cut waste. So when I say that in this point that the very short time frame that sprints have sometimes make teams focus only on what has to be done to get a function out the door. Somebody could argue, well, that's the only thing that you should be concerned about is the function or the user story, the value to get into the customer hands. But we have to remember that there's good software development practices that go along with what people are calling Agile these days. A lot of the XP practices like continuous integration and test-driven development and the focus on unit testing, and there's good software development should be done. I'm not saying that we should have a big heavy process, but even if you have a short time frame, you should still do code reviews. Code review is going to be is going to mean that you're going to release better software. So there's good software development practice that may not necessarily be essential in the rush of the short time frame to get something done. So so technical debt, not wanting to accrue technical debt doesn't mean throw out good software development practice like code review. Another reason why technical debt happens is you may have a weak Scrum Master who's getting bullied all the time on following good Scrum or Agile practices, and you may have an overbearing product owner who is either pressuring the team or is accepting things as done when really the foundation isn't there to call it done. And also, unexpected things happen. When you, as I said, software development projects unfold. So when you get in the middle of a project, things happen that you have expected. So technical debt happens. Not all technical debt is bad. Technical debt is a normal thing. The problem that organizations are having these days is how do you manage it and how do you deal with it. So I want to talk a bit about some Agile and Scrum basics to help us better understand technical debt and to try and fix some of the problems. What we want to do is we want to avoid becoming Scrum butts. If you don't know what a Scrum butt is, go look it up. A Scrum butt is someone who says, yeah, well, we do Scrum, but we don't do unit testing. We do Scrum, but we don't do continuous integration. We do Scrum, but we don't automate our testing. So a Scrum butt is kind of Scrum in name only, or Agile falls. Agile falls is my favorite set of bad practices that people are doing these days, which is using a traditional like waterfall type development but calling it Agile. So Agile falls. The main indicator of bad false practices is handoff, and we'll talk a bit about handoff later, where one team works and then they hand off the product, hand off their work product, rather than having the development be a cooperative, iterative, integrated process. So we want to be careful not to have Scrum butt and Agile false practices. So some Scrum and Agile basics to help us prevent technical debt. Your Scrum Master has to be an expert in Agile and Scrum. They have to fully know and fully understand everything about Agile and Scrum, and they should be the Scrum police, not testers. So we need the Scrum Master to really be Scrum police. And when processes aren't followed or they break, recognize it, report it, communicate it, use the sprint retrospective to its fullest. Right? The idea of Agile and Scrum is not to cut corners. Right? There's this great set of discussions that's becoming famous now about Scrum being like chess from the inventors of Scrum, Sutherland and Ken Schwaber. So this idea that Scrum is like chess. Chess has rules, right? You can move a knight, for example, up 2 and over 1, or up 1 and over 2. You can't move a knight a different way. If you move a knight a different way, if you move a knight at an angle, you're just not playing chess. Scrum has very specific rules, and those rules need to be followed. And if you're not following those rules, you're not doing Scrum. You're doing something else. So I tend not to be so hardcore about it. But by the way, the final part of that analogy, there's 1,000 strategies to how you play chess, right? There's 1,000 ways that you can play chess, but the rules to chess are very specific. So there's lots of different strategies you can use for Scrum in these inventors' mind, but there's rules that you have to follow in Scrum. So that's a very purist kind of by-the-book definition of how you follow Scrum. But it is important when some basic, if you're doing Scrum, if you're calling yourself, you're doing XP, when extreme programming, when the processes aren't followed or they break, recognize and communicate it. That's why you have sprint retrospectives. That's why we try to figure out what the root cause is and fix it. Also, another Scrum basic is understanding chickens and pigs. If you don't know chickens and pigs, go look it up. We don't have time to talk about that here, but chickens meaning like the bosses, the people who don't work on the software, on the product. Chickens need to be made more aware of velocity and what velocity means. That a team can only get a certain amount of work done during a sprint to stay at a sustainable pace. And the realities of what can't get done. And also the chickens have to stay out of the pigs' way. Pigs are the people who actually do the work, who are running tests and writing code and writing documentation and doing whatever that they have to do to get the product out the door. They work directly on the product. So chickens have to stay out of the pig's way, and that's a Scrum Master's job to do that, to keep pressure down. Another Scrum and Agile basic is it's really important to accurately measure burn down and velocity. That's just kind of obvious for how you can scope your work better in a sprint based on what your velocity is. You will prevent accruing more debt if you stick to your velocity. So some more Agile and Scrum basics. A story is not done if there are bugs or issues to resolve. If there's still open issues or open bugs on a user story, the story is not done. Right? And a product owner accepts a story is done. If there are shortcuts taken just to call something done, point them out, call it debt, but it's the product owner that's accruing that debt and needs to be made aware of that. And one troubling practice I've seen developing is where some teams may split stories at the end of a sprint to say, well, we had an 8-point story, and the programmer got the story done. We ran a couple of tests. It kind of worked, but we didn't run these other tests, or we haven't done all the tests we wanted to. Say 5 points of the 8-point story got done, and split it into a second story where we have 3 points worth of testing that have to get done. That is really problematic because it's going to skew the velocity, skew the burn down. It also means that maybe the estimation wasn't done right, or the things are getting to the test team too late in the development. Splitting stories is indicative that there are other problems going on, and it's a bad practice to start. You also have to have a great definition of done. For some Agile and Scrum basics, definition of done is growing into a key practice, having a great definition of done to have successful Agile teams. If you don't have a really strong definition of done, it's going to lead to more technical debt. We're going to spend a lot of time later on in this presentation talking about definition of done. And then another good Agile and Scrum practice is the use of spikes for R&D or hardening regression sprints at the end of development before release for integration. These two practices will help teams reduce technical debt. All right, so now I want to talk specifically about what's going on with technical debt and testers. So there are a couple of situations where technical debt accrues that are of particular interest to test teams. One where they happen at us, where technical debt is kind of tossed at us, and secondly, there are times where we create technical debt. So what I want to do is pay attention to these situations and recognize them so that we can do what we can do to try and fix them. A note about the word testing or tester. Now, we know that by the book Scrum, because Scrum is really what the practices that most teams are doing if they're calling themselves Agile. By the book, Scrum does not include a role called quality engineer or quality assurance or testers. So when I say the word tester, what I mean is the people who do the work that traditional testers did, running test cases, writing automation testing, an API or a UI, writing the regression suite, writing the smoke tests, running those things. Different than the person who's doing the unit testing, the person who's a programmer and then running unit tests. So most organizations that are calling themselves Agile these days are still have a group called QE or testing, even though we know that by the book Scrum doesn't include that. So what I'm talking about is the people who are executing the tests that traditional testers did. So the couple of issues that I want to talk about specific to testers are general testing issues, what I call going over the cliff, the definition of done, test automation, and risk assessment. So first, general issues about testing and technical debt. There are a couple of situations where debt is kind of tossed at us. First, that some teams are under intense pressure to deliver on a fixed date. To deliver full functionality on a fixed date, rather than if a story isn't done, it just goes in the backlog. You stick to the date, but what gets delivered, the number of user stories or the number of points of customer value that get delivered is meant to be dynamic in a project. When we make a commitment, we do everything we can to stick to that commitment, but the idea is you get it done rather than just deliver the function. So for a lot of teams, there's this pressure to just say it works rather than respecting the team's velocity or doing a thorough test coverage job. That many teams have no agreement on test coverage. There tend to be a lot of testing tasks that go undone. The closer you get to the sprint, the end of the sprint, if the team is behind, there'll just be testing tasks that are dropped. And reduce test coverage and build technical debt. So that's probably the situation that's thrown at testers is just cutting your test coverage. That's accruing technical debt. And that's not to say, for example, that things like load testing or performance testing or benchmarking have to be done on every single sprint. You may not do them on patches. You may not do them on every sprint. That's fine. I'm not saying that you have to run every single testing task in every single sprint. But at some point, you probably owe the product performance testing. At some point, you're going to owe the product benchmarking. So there has to be an agreed upon amount of test coverage before the sprint starts for you to be able to call something done. And the testing task gets squeezed at the end is just and dropped is not a good thing. Another problem with testers and technical debt is there are still some organizations that don't include testers or testing in the user story estimation. And this is a persistent problem that really is not happening in your organization. People who don't test, when they estimate how long testing will take, they always underestimate it. They don't understand the full breadth of testing, and they tend to cut corners, which is going to have bad estimates. It's going to throw off velocity and just increase technical debt. And we have to remember that there's always going to be bugs. If it's software, it has bugs, right? But as I brought up a little earlier with bugs, bugs are a side issue. Bugs aren't necessarily technical debt. If a team decides to fix a bug, there's no debt incurred. If a team decides, well, we're going to defer this, or we're just going to make it a user story in another sprint, that's actually normal technical debt that happens. It's where there might be pressure to either minimize or ignore bugs. That's what's going to really increase technical debt over time. So I want to talk about this handoff thing that I brought up a little earlier. That when the Scrum Guide that defines a lot of the practices that any team calling themselves Agile is doing, explains cross-functional teams. This description promotes iterative design, collaboration among team members, cooperation, communication, and it shuns handoff, where one team works and then that team finishes and hands it off to another team. That's not what Scrum is. Scrum is meant to be, and even Agile in general, is meant to be collaborative and cooperative with full communication. It's not meant to have handoff. This idea of handoff is what I see in practice today is one of the main causes of technical debt. One team works, they stop, they throw it over. You know, in old software development language, you know, they throw it over the wall at the test team, and then the test team gets it and tries to figure out what's going on. That level of separation is always going to build debt. Testing has to be involved throughout the whole process, throughout the design process, and collaborate on what a function is going to look like. That's really what Scrum is meant to. So for integrated teams, this means sitting together. This idea of a bullpen or sitting in a war room has been lost on some teams, where in an effort to get more work done or to be more efficient, teams sit in separate places. This is not how Scrum teams are supposed to work. They're supposed to sit together and have that collaboration, which is going to go a long way toward reducing debt. So it's anti-Agile, actually, when programmers work in isolation and then hand off work to testers just to validate it and call it done. So this handoff thing, otherwise known as Agile Falls, it's really a dirty word in Agile, and there's this one organization that I'm thinking of in particular where it's a famous company that everyone would know, that when I went in there to do this consulting job, within the first half hour, they talked about the programmers' sprints and then the testing sprints, that they were separate things, that the programmers would work and they would have their sprint, and when they were done, they would hand off to the testers, and then the testers would have their sprint. And I said, that's called waterfall. That's handoff. And they completely misunderstood what Scrum was about, what a Scrum team was about. That's classic Scrum butt, is saying you're following Scrum practices, but sticking to old, outdated software development practices. So if you recognize any of these Agile or Scrum basic practices that are broken, your team may need to tighten up, have an extra long retrospective and tighten up your practices. And I want to talk a bit about documentation right now. In many organizations, when testers don't document the tests that they create, that incurs debt. That is going to accrue debt. Now, I know documentation is a very political topic these days, with how many lean software development practices have become mainstays in Agile. Let me jump for a second to lean, and I take this definition from Wikipedia. Lean software development has 7 key principles: eliminating waste, which I think has had the biggest impact of anything in all these Agile practices, where people will say, well, the documentation is waste. Test cases is a waste. Test plans are a waste. Architecture diagrams are a waste. Design docs are a waste, so just stop doing them. We'll talk about that in a minute. The second principle, building quality at every step. Quality user stories, quality code, quality unit tests, quality test cases, quality automation, creating knowledge. Decide as late as possible. This is that just-in-time practice that really has its benefits, and it may also help your team accrue debt. Delivering fast delivery, get it in hand to customers as soon as you can. Respecting people, empowering the teams, and optimize the whole, see the whole. So that's some basics of lean software development. I think anybody who's trying to do any Agile practices these days should go and do more reading on lean, because lean, in my opinion, has been this stealth set of practices that have a bigger impact in Agile that most people give it credit for. The one that I want to focus on, the principle that I want to focus on here, is eliminating waste. Once a lot of organizations moved to Agile and Scrum, many teams stopped writing test plans and stopped writing test cases, stopped documenting test cases. There are other teams that stuck with documenting as much as they did, even though they have to be so much faster. Right? So these sprints are fast, there's this need for speed, but then they're making demands on testers that they write as many test cases, they document as many test cases as they have in the past. Those are two extremes. Stopping documenting is a bad extreme, and continuing to document as used to is a bad extreme also. What lean is saying is only do what's essential. So many organizations have to re-examine how much documentation is essential. Do we have to document every test case? Probably not. Can we get away with documenting no test cases? Probably not. So I think that most people on this call, most people who test, are going to agree that documenting every test case has a lot of waste. But the idea that we would be documenting no test cases and cut our documentation to zero, that's just as problematic. There is a big benefit to having a strategy. Now, that doesn't mean write a 50-page test plan like we may have in the past, or even a 10-page test plan like we used to in the past. But there's a benefit to having a test strategy. And having test cases is going to provide for knowledge transfer. If I don't document any of my tests, I may be stuck on a project for a long, long time, for years after I could have been promoted or after I could have moved to a more interesting project, because I'm the only one who knows how functionality works. I'm the key tester on that functional area with how it gets tested and with the automation. So if I don't document anything, there can't be any knowledge transfer. I'm going to be stuck on that project. So how much you document should be examined. So documenting zero is too little. Documenting everything is too much. But when you're not documenting at all, you're creating technical debt. All right. So then there's this idea of what I call going over the cliff. Testing has always been crunched. Hans Bewalda has this great image that he uses a lot about testers getting crunched. So people, they spend some time writing their specifications, they spend some time in development, and they theoretically spend some time testing, and then you have a deadline. But what more happens is that it takes longer to write the specs, it takes longer to specify the product, development takes a lot longer than we expected, and testing gets crunched. So Hans uses this idea in terms of the need for automation. But I want to talk about it in a different in the Scrum situation. So we have these burn down charts that everybody's familiar with, the ideal, the theoretical burn down, where you have this theoretical, we start out with a certain number of story points, and this is how many story points we're going to do in our 10-day sprint. And in the beginning, the developers are delivering points to us, but not too many in the beginning. They're still writing code, and they're still writing code. And at a certain point, they're going to get a bunch of functionality to us to test. And toward the end of the project, toward the end of the sprint, there's just a couple of points that we're cleaning up and a couple of little things we're cleaning up, so that at the end of the 10-day sprint, we get everything done. That's ideal. But the reality is this problem where we have all these story points to get done, and none of them, a couple of them are getting passed to us, maybe a couple more are getting passed to us, but we have all this, we're waiting for all this functionality, waiting for all these user stories to get done, waiting for more tests, and all of a sudden, a day or two before this is done, we get dumped all of this functionality to do in a day or two. We're testing an entire sprint's worth of functionality. What's going to happen there? This is the crunch that happened in the old days. This is the situation where a lot of testing tasks are just going to be cut. We'll validate something. Maybe we'll just do a couple of data points, show that something works at a minimum function, but not be able to do the full array of tests that we planned on doing, not to be able to run as many tests as we wanted on as many platforms, configurations, devices, whatever your application needs, and we won't be able to automate that testing, or we'll start building automation debt just because we sat around and did nothing for the first 8 days of the sprint, and then we get dumped all this functionality at the end, and we go over the cliff. I have to say I used this idea with a very different topic at a conference a couple of weeks ago, and when I put this slide up, it was the biggest reaction I got out of the audience. They were laughing, and I stopped the presentation for a minute, and I said, how many of you are in organizations like this where you get dumped a lot of functionality at the end of a sprint? And more than half of the hands in the audience went up. And they said, this is our number one problem, that we're getting functionality to test way too late in the user story. In the sprint, you are absolutely going to be accruing technical debt if this is your situation. And if this is happening, this is really the Scrum Master's job to fix. This shouldn't only be testers complaining and testers saying, look at what you're doing to me. This is really the Scrum Master's problem to fix. But this is a pattern that I see in some organizations that is really bad and needs to be addressed. So I call that going over the cliff. You get to this point where you just get dumped on too much. All right. So there's no way that the team can do an effective job there. That's where you get into these situations where someone can say, the story is done, but it's not tested. Or, well, it's done, but we're going to test it in the next sprint while we're waiting for the new functionality to be delivered. That kind of handoff is really an Agile Falls process. This is the situation where where some teams would have a bad practice and say, we're going to break it into two stories. The coding part is done, but the testing part is not done, so we'll break it into two stories. That I said earlier is really going to mess with how you measure your velocity. There are teams that would also just say that it's done, and if the product owner finds a bug, we can write a new user story for the next sprint about that bug, but if the product owner doesn't find a bug, we're just going to say it's done, even if it didn't get tested adequately. There are a whole lot of more creative and flawed ways that the teams are pressured to say that things are done just to count the story points. But all of these situations that we just talked about will be accruing more time. And the point that I'm trying to make here is that it's very important that testers point this out, that we highlight these situations, let the Scrum Master know that these have to be addressed during the retrospectives, and do what we can to fix it. So next topic, definition of done. First, let me say, any team using the phrase done but not done done, any team that says done done, you should know that you're accruing technical debt just by having that phrase done done. Something is either done or it's not done. There should never be a difference between done and done done. The Scrum Guide that I referenced before, available at scrum.org, where, in my opinion, most of the practices that people are doing these days come from the Scrum Guide. And let me say something about the Scrum Guide. It's available at scrum.org. It's available in, I think, about 35 different languages, and it's about 21 pages. They just edited it. They put up a new edition of it last year. I think it's 21 pages. It would take you, in whatever language you care to read it in, 2 hours to read. You know, and it really defines some of the basic foundation practices of Scrum that a lot of teams are using, whether it's extreme programming or Agile or whatever you're calling your development paradigm these days. The Scrum Guide defines them. So the Scrum Guide stresses that a team needs to have a very clear definition of done, the DoD. And what is becoming clearer over time is that not having a very strong definition of done leads directly, more directly than anything else, to building technical debt. A couple of the situations that I brought up before where a product owner can get a demo, and if they don't find a bug or they see it, they'll just say, okay, it's done, without having the information that the function has unit tests. The function has been code reviewed. It's been automated, and there are regression tests about it. They tested that it has this agreed upon level of test coverage. All those things that should be in the definition of done are what will help you to not accrue more technical debt. So in some organizations, this idea, this definition of done, has morphed into old waterfall style milestone criteria, entrance and exit criteria, where you have this set of criteria, but when it gets close to the sprint being done, you can say, well, it meets 5 or 6 of the points for definition of done, but it doesn't meet these 2 or 3. We're still going to call it done because we have to get it in the hands of the customer, and just ignore those other 3, or we'll fix it later. That is the definition of building technical debt, right? And this is a problem. When you have a definition of done, this is actually one of the important things about Scrum practices, is rather than having milestone or entrance and exit criteria, which is based on a phase in traditional development and waterfall style development, exit criteria is based on a phase. Definition of done is per user story. So if an individual user story meet that definition of done, the sprint is going to end, and certain functionality can be delivered out to your customer. But that user story, if it doesn't meet the definition of done, goes back in the backlog. So definition of done is meant to happen at the individual user story level, which I think is a brilliant addition to Scrum. It still lets other functionality go out, and we don't compromise our work. So having a solid definition of done and making sure that user stories meet this definition of done without compromising is going to help you reduce technical debt. So a strong and enforced, just what I said, a definition of done is going to prevent technical debt. The DoD has to be enforced. It's enforced by the Scrum Master, not by testers. And just don't even use that phrase done. If teams are using the phrase done, that should be brought up in the retrospective, that just by definition is accruing debt. All right. So I want to talk about automation a bit and try and get done in the next 5 minutes so we can leave some time for questions. So in organizations these days, and in common definitions for technical debt, not having test automation is accruing technical debt. It's what you owe the product. So if you're not automating your tests, that's accruing technical debt. Automation, test automation in Agile is essential. It's not optional. And the levels of automation the teams need: unit testing, always done by the people who wrote the program, right? The programmers, because they need that intimate knowledge of how a chunk of code works to write the unit test. But then we have user story acceptance criteria automation, the high volume regression automation, and automated smoke tests that are part of the CI process, part of the continuous integration process. So that I say that the test automation is essential and it's not optional, that doesn't mean it's easy. There are a lot of organizations that are struggling with that these days. That's the topic of a lot of different webinars. I'm not going to focus on how difficult that is or how you accomplish that. The important part for this conversation is that it has to be done, and when you don't do it, it's building technical debt. So the need for speed and having these really short cycles is with automating. Right? Throwaway automation does not work. There's this idea that a couple of people put forward since we've moved to try and be more agile, that you can develop, let's just say, quick GUI record and playback test cases. They're going to work in this sprint. They'll be fine for this sprint. But then after this sprint is over, anytime that you do anything to change the UI, anytime you do anything to change the functionality, those throwaway tests are going to be useless, and who cares? They're low value. We'll throw them away. that's really a bad idea because in the long term, you're just the interest rate on that debt is going to be gigantic, and you're not doing yourself any favors. You're not going to have any long-term benefit from automation by using throwaway automation. I've yet to see any company use that throwaway automation idea and have it be effective in the long term. You know, sometimes I feel that people are pressured to do that. Maybe it might be a benefit in the very, very short term, but in the long term, it's going to cause more problems than it's worth. Also, test teams will accrue more debt when their automation suites lose relevance because of maintenance costs, because they're not upgrading their infrastructure, or they don't use intelligent test automation design. That's really going to be a drain on resources and no help to testing, and have high interest technical debt. So also from my experience, when teams are struggling with technical debt, they rarely account for test automation as part of that technical debt, yet if you had better test automation, you could easily be reducing technical debt. So one thing that I would suggest you try is try automation sprints independent from production code sprints. This has been really beneficial for a lot of organizations where the testing that happens inside the production code sprint, it might be manual. You're using your continuous integration automation. You're doing your high volume regression testing on the production code, but building new functionality, automated tests, happens in a separate sprint. Building out the framework and maintaining the automation framework independent takes a bunch of pressure off of the testing to build better automation. That's going to really be a long-term benefit and reduce technical debt. So since it is software development, since automation, test automation is software, the development should be treated as software development, where you're going to be testing it and having code reviews and doing those good things for automated tests to have it be the quality that you need it for long-term benefit. So that's what's going to reduce the high maintenance costs and reduce technical debt, is when you treat automation like its own development project. And I want to make a note here that there's significant research being done these days on test automation project problems and test automation and technical debt. There's a great paper that was just published. It's available, called Technical Debt in Test Automation. And I have a few links to some other papers. These are going to be available in the PowerPoint and available on this presentation. That talk about just this issue of automation problems and how they increase technical debt, and how you can use automation to cut technical debt. So that would need its own webinar just to talk about this individual topic, but I have these links here for you to go and read some of these research papers. It's great hearing, it's great seeing real research and empirical data rather than just opinions or marketing jargon. So technical debt can really be reduced in the long term with better test automation, and we're going to leave it at that for the sake of our conversation. I have 7 papers referenced here that talk about technical debt and test automation. So the last topic in testing and technical debt is risk. I always think that one of the most important skills need to build is risk reporting, risk analysis, risk management. Remember, all of our bugs are risks. So much of what we do, particularly because we do most of our work at the end of a sprint or at the end of a project, is risk management and risk analysis. So I think one of the ways that testers can strongly impact accruing technical debt is by being better at recognizing risks, communicating risks, reporting risks, assessing risks. That we can give lucid and pragmatic, unemotional, clear, direct risk analysis is going to help the team prevent accruing more debt and provide better risk analysis when we have to accrue debt. So just because of the nature of our work, because we spend more time in the product than anybody else, we have this special need to recognize, analyze, and communicate risk. Important for to do. So our risk reporting skills can help reduce technical debt, or our risk analysis skills can help the team assess whether they want to take on that debt or not. So to finish this, I have some recommendations about preventing debt for the whole team, not just for testers, for the whole development team, from Ted Theodoropoulos. How to prevent technical debt: document system architecture, implement coding standards and conventions, properly understand the technologies that the team is using, understand the processes the technology is designed to support, and refactor. Right? That's how the team can prevent technical debt. Specific to us, for testers, we can prevent debt by improving estimating skills and learning from our mistakes. Estimation, user story estimation, is one of the first steps that we can take to better estimating our stories. Better estimating the testing is going to help us prevent accruing. And we can also prevent technical debt by investing heavily in test automation. The payback, the ROI, the return on investment that you're going to get from test automation is undeniable, right? But and sloppy test automation is going to accrue more debt. I'm not saying that this is easy. I fully realize that it's difficult for teams to keep up with the amount of automation necessary, but there are things that you can do to reduce the debt that test automation accrues. Technical debt is similar to financial debt. Ignoring it is the worst possible outcome, right? Ignoring our debt is the worst possible outcome because interest just keeps going up and up and up. So make the debt visible. Recognize debt, state it, write it down. Alex Pokinskis has this great suggestion that if you're using a Scrum board or a Kanban board, you use a fluorescent pink index card when it comes to debt. Maybe all your other user stories are a normal color, yellow or green or white, but use a hot pink fluorescent index card when it comes to debt so that people realize what it is that you're putting off work for later. Service the debt. You have to deal with it sometime. If you just accumulate too much, all you wind up doing is spending your time paying your debt down. And one of the things I'm going to say on the next slide, I'll say here, when I talk about servicing the debt, there are people doing research, and what the published research is seeing these days is the teams that are accruing higher technical debt, their velocities are going down. And if you do an accurate measurement of velocity, servicing the debt becomes the focus point of the development teams rather than releasing new value out to the customers. When the debt gets so big, servicing that debt becomes the focus, and that's going to be seen through velocity decreasing and not velocity either staying the same or increasing over time, velocity going down. So pay attention to velocity. That's going to be an indicator of how much time you're spending servicing the debt. Also, get a good definition of technical debt. What I started on here is one of the first most important things you can do is just have a good definition of technical debt. Remember that the original definition was only about refactoring. Most organizations have had to move past that, but get a good definition and agree to it so that you can realize what you're putting off, realize what you're delaying, and deal with it better. Use spikes to better understand user stories that may not be clear or may seem too big, and then pay attention to velocity I just mentioned. So to summarize this, technical debt it's inevitable, right? It's software development. There's going to be technical debt, but it's not all bad. It has to be recognized, communicated, managed, serviced, and when teams are chronically in debt, that can really have a team implode. It can have a product implode and have devastating effects on morale, on your customers, on the product itself. The debt has to be serviced. So that's it for me for my presentation, and we have some time for some Q&A if anybody has any questions.
Thank you, Michael. Actually, we have really one question. I think most of them were the questions that came in. You answered them as we went along. But they had a question is that undone work or really work that is not started, can that be considered technical debt? And I guess it would be would it be work that is essential would be considered technical debt? But you're the expert on this.
Okay, that's a great question, and there's one client that I have where that's exactly the problem that they're having now. So they have this very complicated branching structure in their source code, their source control system, very complex branching that needs setup and it needs management. Every time they do a new product or a new development piece, they're trying to do a lot of shared components, and they're trying to a uniform platform, platform for all of their customers. They have this very complex branching structure, and it requires investment. It has nothing to do with the individual user stories. It has nothing to do with the functionality that gets released out to their customers, but this is standard work that has to get done for every release, even though it's not associated with a user story, with any user stories at all. And the problems that they're happening, the problems that are happening at this organization, the product owners are pressuring the team so much to get the new functionality out into the hands of the customers that the programmers who have to do this work in the source control system this investment on every project are behind schedule every time, and they've struggled with, well, do I include that time in my estimates for the user stories that have nothing to do with the source control system? Do we write a user story that's going to happen on every project as overhead about the source control system, about this branching that has to happen every time we do a new release? How should we handle it? So to answer your question, there's a lot of technical debt that comes from infrastructure, from building infrastructure, that somehow you have to capture that. And the one reason, I'm not going to tell you what this organization did, because every situation there is probably going to be unique. Whether you write a user story by itself or the infrastructure that has to be built that has nothing to do with the user stories that are going to be functionality delivered to the customers, or whether you just include that that overhead, the amount of time that we have to spend building out that infrastructure, you kind of spread that into the user stories. I don't like that idea because it kind of throws off the estimating skill for individual functional user stories. But this is one of the times when companies would do a spike, or do what some companies call an iteration zero or sprint zero. That I know that these are political terms that they're kind of loaded guns, whether people like that idea of an iteration zero or a spike just for infrastructure. I don't agree or disagree with any of those, because in the end the team is going to do what it takes to work. The key is you have to invest that time in infrastructure, invest that time in overhead. That, to answer the question, it doesn't have anything to do with the individual user stories, but it is a major impact in accruing debt. This particular organization that I'm thinking of was having serious problems with their branching because some people were doing that the proper branching that had to happen at the beginning of the projects, and some teams were under so much pressure from certain product owners that they weren't taking the time investing and thinking, well, we'll just fix it later. I can just go clean this up later, and that later never came. So so the answer is, yeah, a lot of the technical debt is about infrastructure and overhead that isn't about individual user stories.
Okay, well, Michael, we're past the hour, so we will soon let everybody go here. If you'd like additional resources, you can always go to LogiGear.com. We have a resource page that has, you can go to the tab, and it's all about Agile and testing resources there. So that's LogiGear.com. We also have a magazine that we publish not quite every 2 months, but we're getting up to that. It's called LogiGear Magazine, and you can go to LogiGearMagazine.com. A lot of great articles in there, past articles on Agile. And then also, if you're interested in test automation, go to testarchitect.com. And if Michael is available for consultation and training, so if you'd like to arrange for Michael to come out and get a consulting engagement with you, just simply fill out a contact us form on the website, and we'll be glad to help you out with that. So with that, we thank you, Michael. It's been very informative, and thank all of you for your time today.
Thank you. Thank you. Thanks for everybody coming today.
All right. Bye, everyone.